Hello and welcome to another free code session. My name is Jason Bach and let's keep doing some bit masking, twiddling fun. I'm not going to record another episode tonight. This will be it. But I think I have this right now so that you are checking to see if the current one is set and then how you move to the next one with this weird piece of logic in div_rem, I think is going to be correct. So, God, I hope so. I could see this going very wrong. The thing that I'm actually looking at now is, oh yeah, it's not B, it's R. So we move over R. Because we are at B, and either we're going to move to the right, and that remainder is what's actually saying how far should we push the bits in. This is, now that I think about this, no, that's the 4. Yeah, okay, that's right. That's the 4, the +4 here, because that's putting in the 4 bits that are the new position of the blizzard. Okay, but it does have to be R here. That is correct. And so if this went all the way around to 0, this would be 0, and you wouldn't be pushing them over any farther 8 than you would need to, but it does do a +4 there. And it does do it at the, what would be the 0th on the X. Yeah, I think this is correct, but I'm pretty sure this is all going to just be wrong. I'm sure it is. Now, let's say up. We go up. So what do we do when we go up? Let's get rid of these and get rid of some red there. So if this goes up, we would not change the Q that we're looking at, nor would we change the B that we're looking at, because it's going to be in that same position. So we don't need to do this. But what we need to do is this. Yeah, and these Q's are because we are doing that div_rem here. This would actually be an X. This would be that. This would be X. Oh, you had it. And so we're going up 1 in our array and setting the up moved over times 8, except this is, yes, that would be B. This is the actual location into the grid. These also have to be that, so yes. And so then I think here we would also do down, except we're going to say down. And we go down. Okay. And to go down, you just do this. Except you do down. There we go. Now, to the new bits sections. Okay. Now move all of the new bits to the current. Now we're going to say now clear out all the current bits and move all the new bits to the current bit locations. Okay. So we do that and then that. That's essentially this, except not. And this is going to be grid of X and Y is going to be equal to grid of X and Y bit masked with SD24 dot, well, you have to expand all that out. Come on. 24. Current. Where's the bit mask thing? Clear current mask. So this is, again, going to keep what we just put in as all the new bits, because we're ANDing all these, and then we're going to clear out these so that the news stay and the currents go away. Okay. But then what we need to do is to right shift 4. Because we need to do, 1, 2, 3, 4. We need to shift them over 4 bits. I think that's right. Okay, so now what we can do is we need to see if the starting position is open, except sort of. We need to actually look at 0, 0 with the real 0. And so it's actually pretty good in that we want to look to see. Yeah, this was a little simpler because this was easy to say, well, you equal to none. We can't really do that right now. And this is also, I thought about this when I stopped recording on the previous one. The expeditions X are the true X, and of course Y, but that's not, like what set of bits in an X. This is 0, this is 1, this is 2. So that's going to be fun. So this one is basically saying that are the lowest 4 bits equal to 0. We started from the bottom, we moved to the top. The top is actually up there as max y minus 1. And we just want to say, and 0b, 0's 1, 1, 1, 1, 1, 1, 1, 1. Okay. No, this is where the boolean logic always kicks me in the butt. I don't care about any of these upper bits. All I care about is the lower 4 bits. I think I need to do the reverse. One, two, 3, 4. 1, 2, 3, 4. And so what we're saying is all of those upper bits, doesn't matter what they are, they're going to be 0. These, we're hoping that what's in that grid position have zeros there, because then the whole thing should be equal to 0. And you're complaining because why? Oh, yeah, there. Okay. So now what we can do is say, move the expedition into 0 at that minutes. Okay. Can it go right? Wow. It's so critical to get these right. And then this is the only section left that we have to do anything at. So what are we trying to say here? Can it go right? Why am I doing max x minus 2 here? Because the max x, that's definitely wrong. That's the length. And this is also expedition quotient. Expedition remainder. I bet those are going to be very helpful. Int div rem. Because we need to take expedition x and do a 4 on it. Because that will actually tell us the right, like 12, 3 quotient remainder pair. This is x length minus 2. Because that's actually it's the actual physical length or logical, one or the other. And now what we want to do is we want to say, does the one ahead of it, that's right. Because if you're at a wall, your x length minus 1, their x length you couldn't go to, right? This is basically saying you're 1 away from the wall, and now you're trying to move towards the wall, right? So what you do want to do is here's the quotient, except and this. I mean, I guess maybe something I'm doing in here is totally screwing up everything else. Probably. So we're trying to get this, except we're trying to see if now it's a none. But what does that mean? It means it's like this, except the bits are all moved over. Like this is for the 0th. That's why you're saying 0 here. It could be 0, but you're looking at 1 or 2 or 3. So what you want to do is say and this anded with left. We want to do, we don't want to keep doing this. What I want to do is say like that and 0b 1 2 3 4, except shift it over expedition remainder times 8. There. Okay. So now what you can say is if expedition x plus 1 would equal the total logical length minus 1, and then y is 0. That means you're in the bottom row, you're all the way to the right. You could now move down 2, and you're there. Because you're going to move over there, you can move down. Everything stops, you return that. Okay? Now, this expedition plus 1 is correct because, again, that's the logical one. So we're just moving that over. I believe that should work. Can it go left? Is x greater than or equal to 1? And yeah, this is not true. Because, again, it's a thing we just dealt with previously, which is what happens if you're at 4, 3. So your quotient was 4, your remainder was 3. That means you were 16 plus 3, you're at 19. 20 is going to push you over. So what you need to do is look at the correct spot. And I believe when I look back on editing this, I'm going to be like, you were just babbling up a storm. And I know there's a bit vector 32 thing that if I use the bit vector, but I know that's not really what I want to do here, I don't think. It would probably make some of this logic a little bit easier, but probably not, because it's still, yeah. Nevertheless, we are trying to move toward the right. We're trying to actually see if the thing to the right, which could be the next set of 8 bits, or it could be the lowest bits on the next thing over, or, you know, but that's the thing here is we're bounding it so that you're actually not gonna, you're not a blizzard. You don't bounce over to the other side. That's why we're doing all these checks like -2 and that you're greater than 1, because you can only move over the 0. If you were at 0, you couldn't go down anymore, is what that's saying. So if you're at 1, that's fine, but if you're at 0, you can't. So this one is saying that, but we could still have the case of you had 101 characters. So you could have been at the 100th character, which would have been 24 times, because if you're at the 100th character and there's 101, like I'm just saying, what you could get to that condition where whether you're at the edge or whether you're coming, you could hop over to the next thing, and that's what you're actually trying to look at to see, does it have anything in there? Does it have any kind of blizzard? Because as long as if it has a blizzard in it, you can't go in there. Okay. So what you really need to do is look at the next set. So we could just do a +1 here. Well, yeah, this gets a little squirrely because we can't just do a +1 here. We're trying to see if it goes right. And to see if it goes right, that's a different set of these because that's going to affect this and this, but it only happens up in here. So I'm going to try a trick. I've just seen this. Okay. Now it doesn't matter if this actually goes beyond what you're really limited by the number of characters. Okay. This is only for this one, in that if you are less than 2, then that allows you to do that grid expedition quotient, which might be like if you're at 1 and you 1 + 1 is 2, you'd still actually be a grid of 0. But your remainder went up by 1. And so the bits you're going to look at are moved over. And so I think that's correct. Now, what did I mean by this trick? Here's the trick. We're actually going to put these all in their own blocks. And I believe, nope. We're going to just grab this. And we're going to do x -1, except we got to be really careful here because we're good. Because again, we'd only do this if this is 1. And so if it's greater than or equal to 1, 1 - 1 would be 0, and we're safe, okay? But what we're going to do now is say, and grid at expedition x, and this, and that's good. You can put blocks in your code, and that says this expedition quotient is different than this one. And I just saw this like a week ago and somewhere in Mastodon that somebody said you could do this. Except we're missing something here. Oh yes, we need that there. Okay, now that works. And again, this is just a logical x -1, and that's our new expedition. Okay, so that's what I find cool about this, is that it allows you, this, if I didn't know this, I'd have been making different variables. And since I know the conditions that they're bound by these things and these things, it doesn't matter what these truly do until we are sure that we're like 1 in, and then we can do that. Okay. Which is very nice. Very nice. And I didn't know you could do this, like I said, until a week ago. And now I know. So now what we're going to do is nothing here. I mean, we're going to do something, but we're not going to change the x here. Okay, that's still the same bits here. The only thing that we're doing differently here now is we're saying this is a grid of expedition quotient, except we're going to go up a y. Okay. And then we're going to say, and that. Okay. And that should work because that's the remainder. And then we do the last one here because that went up. And so again, the y can go up. That's fine. And then we do this. I know this may look a little weird, and I usually would not do this, except this oddly feels after a couple of beers like this is the right thing to do. Oh, what do you say? I don't trust you. I'm sorry. I just don't trust that right now. Expedition quotient, expedition y -1, and then this little pattern like that. And then we do the same check here, which is x length, though. And then the next move would finish. Because you could be coming from the right, or you could be coming down to that special location at the lower right, and then you'd finish out. And that is X length. That's, again, the reason why we need the true X length. Can it stay where it is? I don't know. Can you stay where you are? This is easy because actually I don't think we need to say all that. I think that's fine because the rest of the bits are going to be 0. So that's fine. But I believe we need to do one more of these. Okay. Do that. And then we can do that. Okay. And so we're going to do that, except we don't change where it is. We're just saying, can it stay where it is? So we're looking at this quotient here at also y and that thing. So we're going to say that and that. And I believe, nope, it isn't. Okay. So now we're just saying remove the whole expedition. We don't care. Otherwise, you keep the number. And we're done. We're not going to test this. It's perfect. There's no way that this could fail. Why are you suggesting this? I don't think that's right at all. Or maybe it's much better than what I could ever come up with. I have the feeling that the next episode is going to be a lot of debugging. That there are things in here that I have done completely wrong, and I'm going to regret everything. So, but this oddly feels correct because this should just all have all the zeros except the ones in there, and we're checking to see that they should also have zeros there because that means there's no blizzards at that location, shifted over correctly, and also at the right quotient. At the true location, not the virtual location. And the X length here and the X length down here are the true X lengths. You're doing X length, also -1 and +1 there. And yeah, we're going to do in the next episode a lot of testing. We're going to test to see did the small thing work first? Because that's what we've been doing here, which is, I think up here, yeah, minimum minutes optimize, and then minimum minutes one grid. If that works, we move on. If it doesn't, we'll debug it till it works. But then we're also going to move, once it does work, we're going to get to the larger one. If that gives the same answer, then it's just a matter of doing the performance testing. But that will be an episode that I record tomorrow or sometime in the near future. Not tonight. Thank you all for watching. Leave comments and questions below. See you in the next episode.